Good morning. Hi, my name is Matt Ray. I'm the Director of Partner Integration for Chef. Let me tell you about Chef. So Chef is an open source framework for managing infrastructure at scale. It's configuration management and systems automation. It handles how servers and networking and storage devices are configured. It provides a declarative language for describing the state you would like your infrastructure to be in. But Chef is also a company and a community. So we're about 200 some people based out of Seattle, and we're growing quite fast. So how does Chef work? Chef ensures that the state of your infrastructure is continuously checked and repaired by implementing the policies that you've declared in a domain-specific language. The domain-specific language is an extension of Ruby, so essentially you have a programmable interface to your infrastructure. What Chef does is it has a client that runs on each machine in your infrastructure that ensures that the policies that you've requested through your recipes are applied to those machines, and the state of that machine is captured, sent to the Chef server where it's indexed for search, reporting, and auditing. Here's an example of a Chef recipe. It's pretty simple. This is installing Apache, the web server. The first resource we have is just the package resource. We're just saying, hey, I need to install the HTTPD package. This is what Apache is called on Red Hat. The second resource is a template. We're doing the configuration file for Apache. So we're using an ERB template. That's a standard Ruby templating format. Setting the group, the owner, the permissions on that file, and then passing a few variables into it. So because it's a template, it's configurable dynamically. And then at the end, if that template changes, if that configuration file for Apache changes, it's actually going to notify the third resource, the Apache service, that has already been enabled and started, but if the config file changes, we need to reload the service. So Chef is based on the idea of infrastructure as code. This is the idea that everything you do in your infrastructure is tracked in a source file that can be versioned and checked into source control. So, Git, Subversion, Mercurial, whatever it is you're using. But what that allows you to do is to treat your infrastructure like any other code base. So you can diff it, you can share it, you can put it up on GitHub, you can open issues against it, you can have comments and code reviews on it. But once you've got your infrastructure as code, what that allows you to do is you can reproduce the infrastructure that you have in any setting with nothing but source backups, data backups, and access to new compute and networking resources. So if you're doing cloud-to-cloud migrations, if you're moving from virtualized to physical or physical to cloud, all those are really easy to do if everything you do is automated. So Chef provides a number of resources built in. It's pretty much anything a system administrator would do on a system. So things like installing packages, creating users, groups, directories, services, and it's cross-platform. So with Chef, you can build anything, whether it's simple applications, you're standing up a LAMP stack or something, or complex things, maybe like an SAP deployment, configuring workstations, clusters of computing, as well as standing up large-scale infrastructure like IaaS or PaaSes or SaaSes. Pretty much anything that you configure as a sysadmin can be done with Chef, especially at scale. And because everything is managed by Chef, you can automatically reconfigure everything quickly. When nodes need to find information about each other, they can contact the central Chef server that has indexed all of the information about each other. So when your web server needs to talk to a database, or your load balancer needs to find the web servers that it's balancing, it just asks the Chef server, where are those machines? And so as your infrastructure scales and changes and nodes come and go, those dynamic changes can be picked up quickly. And Chef is cross-platform. It works on Linux, on Windows, Unixes, BSDs, pretty much everything. And we're working on extending our support into switches and load balancers and storage systems. And Chef has RESTful APIs for everything, so it's very easy to integrate it with external systems. And you're probably telling yourself, hey, we're here at Cisco Live, servers are great and all, and Chef can scale to hundreds of thousands of systems, whether they're physical or virtual, but networking is different. It's not as easy as servers. Things happen with networking, and it's tricky, and who knows what happens if a switch goes down. Instead of losing a machine, I'd lose 48 or more. And yes, networking is differently, but that sort of efficiency and reproducibility that you get is very applicable in the networking space. And a lot of the networking devices have a user LAN, so they're essentially nothing but a Linux or FreeBSD box with 48 ports. And Chef is already cross-platform and on many operating systems already, so we've started porting Chef to other platforms. So right now we're working with Cisco on porting Chef to the Nexus 9K and 3K platforms. This is the NXOS platforms, and soon we'll be doing iOS XR. The 9300, 9500, 3000 series. We're going to be releasing this code in Q3 of this year. Everything we're doing is going to be open source and up on GitHub. The way we're doing this is we have an installer for the Chef agent that works on the Nexus devices. So the Nexus devices are running a variant of Linux called Wind River that's RPM based. So we are actually building an RPM of the Chef agent on those machines, and we're using our packaging system called Omnibus. Omnibus is a cross-platform full stack packaging system. What this allows us to do is to provide all the dependencies that the Chef agent needs for any operating system all in one package. So we don't have any operating system dependencies, and we can ensure that we're running the latest version of Chef with the latest version of Ruby and all the security patches for OpenSSL and whatever sort of underlying libraries we have. We bundle all of those up in a single package and install it into opt Chef on the Nexus devices, so we don't interfere with the paths of any other things on the system. We do this for Linux, for Windows, for AIX, Solaris, you name it. Omnibus supports all those platforms. It's open source. It's not just for Ruby applications, and a lot of other companies are using it as well. So once we have this Chef agent built for the Nexus devices, we're going to bring it into Chef's continuous delivery pipeline. The Nexus integration is considered a tier 1 platform, so it will be treated the same as our Windows support or our Red Hat support. So it is officially supported, and we will block releases if something's not working on the Nexus platform. The downloads will be available in all the usual places, as well as through our download API. And a few changes have been made for the Nexus platform already. Those patches have been merged upstream, and so we're currently building off the master branch. Right now we're doing alpha builds, but we will have beta builds available soon through Cisco. The changes that we've made is we've made it so you can detect which platform you're on, which platform family you're on, and then we'll start changing out some of the resources that are specific to the Nexus platform. How we install packages, how users are created, the permissions on files, and that sort of stuff, and validating all of it. A lot of this work is being done in a Cisco Cookbook. So this cookbook is going to be open source soon, but it provides resources for managing the Nexus device as well as NXOS. So there's a Ruby gem that we'll be working with that makes direct calls into the NX API. And with this gem, we'll be able to configure the underlying Cisco-specific things. We'll see a list of the resources here in a second, but it's going to have full test coverage and be part of the open source community, so other folks outside of Cisco, outside of Chef, can contribute to this and test it in their infrastructure and make upgrades as applicable. Here's a quick list of some of the resources that are being worked on currently. Things like VLANs and OSPF and interfaces, all that's going into the Cisco Cookbook. And in time, some of those resources will merge into Chef itself. So the core Nexus support that makes it slightly different from Red Hat or Ubuntu, those will get merged into Chef. But the Cisco specifics, the things that require the NX API, those will stay in the Cookbook. And here's a quick example of what a Chef resource for a Cisco device looks like. Here we just created an interface, and so each time the Chef client runs on this box, whether it's pushed through SSH or 0MQ, or whether it's just on cron or daemonized, it'll go and ensure that this interface has been created and these settings are applied. So you're thinking, hey, that's great and all. I've got my network devices are now managed, just like servers. Well, at Chef, we're really big on the idea of test-driven infrastructure. This is because everything in Chef is versioned and tracked with access controls. Your infrastructure as code can be treated as source code, and once you start, if you're a developer, you've probably been doing continuous integration for a long time. And when you start looking at infrastructure, you can do the same thing. You can ensure that your infrastructure is being tested at each step along the way before you send it out to production. And so there's a lot of testing tools built into Chef, or packaged with Chef. Rubocop is a Ruby code analyzer. It goes through and finds things that may potentially be an issue. Food Critic is a lint tester for Chef cookbooks. It gives you feedback on style, potential issues that could cause problems down the road. Chef Spec is a unit testing framework. So as you write your cookbooks and as you specify, hey, I'm going to, my Cisco resource is going to set my interface, you can actually say, hey, if it sets this interface, I expect the interface to do this. And then Test Kitchen is a testing framework that actually spins up VMs and it installs your cookbooks onto them and then does integration tests with server spec. So you can actually go and say, hey, I said I was going to deploy this Cisco Nexus device, and when I do it, I'm going to set these interfaces, and then server spec will actually go through and say, hey, you've stood up this VM, you ran the Chef client on it, now I'm going to come in and ensure that, oh yes, interface 1, 2, 3, and 37 are listening, and the rest of them are closed. So you can ensure that the tests, that the policies that you've expected to be implemented are actually being tested in place. And once you've built this sort of capabilities into your infrastructure, you're deploying your applications, you're deploying your servers, and now you're deploying your networking with the same pipelines, you're going to want to build a continuous delivery or continuous deployment pipeline and actually control the promotion of changes across environments. Chef has support for environments built in, so you can say, hey, I've got QA, I've got pre-production, and I've got production, and I can restrict with access controls who's allowed to run what in which environments, which cookbooks and which packages are promoted between them. So I can let QA have unfettered access to their own segmented part of the network. They can play over there and mess things up if they want, and once those things are ready, they can move them into pre-production. And then when pre-production, maybe someone with higher permissions can validate them. You do a little more testing. Maybe you've gone from a virtual environment to a physical environment. Maybe you're running in the cloud now. Once you get this process down, you can quickly and safely deliver a value to your customers and get features out to the field much faster. So as Chef and Cisco are starting to work together, there are a couple of strategies that are emerging for how infrastructure is going to be managed at scale. In a Chef-only environment, Chef would actually be managing the switches directly. This can work, and will probably work for a lot of configurations, but eventually you'll probably start looking at things like Cisco's application-centric infrastructure, ACI. In an ACI environment, ACI is controlling the network topology, configuring quality of service and speeds for the networking, and configuring VLANs on the fly. Well, we kind of see a hybrid approach coming where Chef is managing the individual devices, ensuring that the latest versions of packages are installed, users and groups are set properly, and then Chef would integrate into ACI and actually make requests that, hey, I need this VLAN created for these servers that I'm spinning up over here. And so Chef acts as the orchestrator, and ACI handles all the networking specifics, while Chef handles the device and the endpoint devices. So we do have further Cisco integrations in play. We're working with the UCS team with a Ruby library called UCS lib. It integrates with the UCS Manager API, so it actually allows us to create devices, create VMs on the fly, install the Chef agent on them, and so UCS essentially becomes a hardware cloud in a box with an API. And so we can interact with that just like we would with Amazon EC2. We're also, we're working with the ACI team, and then Chef has been part of the OpenStack community since day one, and so we've got integration for all the different OpenStack variations out there, including all of Cisco's deployments. So thanks a lot, everybody, and if you need to get a hold of me, I'm Matt at chef.io. Thanks a lot.